Hello and welcome to another episode of Math with Dr. War. Today we're going to look at the Pythagorean theorem. You use the Pythagorean theorem if you're given a right triangle. Now a right triangle has a right angle and you usually see the little box right here in the corner. You also use the Pythagorean theorem if you have to find a side. So one of the two properties you must have in order to use the Pythagorean theorem is you must have a right triangle, and the problem should ask you to find a side of the triangle. If that's the case, you're using the Pythagorean theorem, which states that a squared plus b squared equals to c squared. Now this formula is given to you on your mathematics reference sheet. So notice here on your reference sheet, here is your Pythagorean theorem right here, where it says Pythagorean theorem. So you don't have to memorize. Now, when you have your right triangle, you have to know who are A and B and C. Now, A and B are considered your legs of your triangle. So I always tell my students, the legs are what forms your right angle. So notice this is my right angle right here. So the legs form your right angles. So this could be your A and this can be your B. These are your legs. So this is a leg and this is also a leg. I always tell students, I don't care which one you label as A or label as B. They are your legs. If you're walking, if you put the right foot first, you're still moving. And if you put the left foot first, you're still moving. But those two sides that create your right angle are your legs. Which means that C is your hypotenuse. So this here is our C, which is our hypotenuse. Now your hypotenuse is the longest side. I always tell students you can identify the hypotenuse because the right angle points to it. So if your right angle points to this side right here, that is your hypotenuse. I don't care how you draw your triangle. So sometimes they draw their triangle upside down. I know this triangle looks awful, but bear with me. Now this is my right angle here, and if I draw a line, it's touching this side. So I know that side is my C, which means this is a leg and this is a leg. And really I don't care where I put the A or B, as I'm able to identify they're your legs. And remember, you have to square your legs and add them together, and you're going to get the square of the hypotenuse. Okay, so here we have to find x. Now remember what I said. Notice they didn't put the little box here, but I know that the two sides that create the right angle, which is here, these are my legs. So this could be A and this could be B, and this x that we're finding is your C. So I'm going to show you two ways that I teach my students. So some students like the formula, so I'm going to write the formula. A squared plus B squared equals to C squared. Now this is my A, which will be 4 squared, plus my B is 3 squared equals C has a value of x. So I'm going to put that as x squared. 4 squared is 16, plus 3 squared is 9. And that should give me x squared. Now 16 plus 9 is 25 equals to x squared. They don't want us to find x squared, they want us to find x. And this is where students get into a little bit of difficulties. Your next step is you have to take the square root of both sides. Now the square root of 25 is 5. And the square root of x squared is x. Because remember from my radicals, solving radical equations, remember this will cancel that and you will just leave with x. Now some people, that don't like to use the formula, because when I taught, let's say, GED, I never taught the formula. I always tell the students, look to see what you have, and they'll say, oh, I have a leg and a leg. So I says, okay, if you have both legs, you're going to square them and add them. So if you have both legs, I always told them to square each leg, add, and then take the square root of the sum. So this is what they did. So they're like, okay, I have both my legs, and she said to square them. So 3 squared is 9. I want to square 4, that's 16. She said to add them. So 9 plus 16 is 25. And then your last step is to take the square root, which gives you 5. I don't know if that method is helpful for you, but that's how I taught it when we did the old GED, because I found students never went to the reference sheet for the formula. Okay, let's try this example. So here I'm finding x. Now I know that the legs makes the right angle. So I am missing a side, which means this, when you take the an arrow from the right angle to this side, that C, that 13 is your C, which is the hypotenuse. Now if you like the formula, you can go a squared plus b squared equals c squared. So I have 12 squared plus, I don't know my b, so that's x squared equals to 13 squared. 12 squared is 144 plus x squared, which is 169. Now solving for x squared, I have to subtract 144 from both sides, and I have x squared equals to 25. And solving for x, I'm going to take the square root of both sides. So x has a value of 5. And that's my answer. Now again, if I did the shortcut, I'll ask the students, what do you have? And they'll says, I have a leg. So you have a leg and you have the hypotenuse. Now when you have a leg and a hypotenuse, you're going to subtract. So if you have a leg and the hypotenuse, you're going to square, then subtract, then take the square root. I'm just going to write the sign. So remember, we're subtracting, so we want the bigger number first. So I'm going to square this. So 13 squared is 169. Then 12 squared is 144. And then I'm going to subtract, which gives me 25, and then take the square root. I find this method is much nicer because some students don't like equations. Okay, let's try some word problems. The diagram below represents the side view of a bike ramp. So you have a bike ramp here. Which of the following is the closest to the value of x? So again, let's see if we can find our right angle. So here, this is our right angle. The 6 and the 26 is making our right angle. So these are your legs, leg and leg. And remember, when you have both legs, because I'm not going to do it the formula way. If you want to do it, that's fine. If you have both the legs, you're going to square each leg. Then you're going to add, and then you take the square root. So I have 6 squared, which is 36. I have 26 I'm going to square. I need my calculator. So 26, and I'm going to square 676. Remember I said when you have both of the legs, you're going to square them and then you're going to add. So notice I squared each leg. Now I'm going to add them. I put my plus sign right there. Okay, I still have my calculator. I'm going to add. Notice when I put the add, it says answer. The answer is just at 676. So I'm going to add 36. I get 712. Okay, remember our third step, we have to take the square root. So I'm going to go second function, x squared, to get the square root function. And I'm going to type in 712. And I'm going to hit enter. Now when you hit enter, notice they simplified the radical to 2 radical 178, but our answers are all in numerical form. So remember our function here, this is going to convert our radical to a decimal. So let's go, let's press that. Notice I get 26.68 and all those numbers. So let's look to see what will be our best choice. This 6 is going to make this increase 1. So our answer approximately is 27. So this is my answer choice. Now, I always tell students, sometimes if you're on the test and you can't remember how to solve the problem, you can kind of guesstimate your answer. Now, x is the hypotenuse, and the hypotenuse is the longest side, which means if this is 26, your answer for x should be greater than 26. So if you have to guess, this is not my answer and this is not my answer. And then always remember your answer must be close to these two numbers. Well, close to this one because this is the largest one, 26. So your answer has to be in the ballpark range around 26. And 27 seems like a perfect choice rather than 32 because 32 is a little bit far off. So 32 is kind of bit far. You want someone in the ballpark range. So 27 seems fair if you needed to guess your answer. Okay, let's look at another one. A 10-foot ladder is leaning against a wall. The bottom of the ladder is 4 feet from the base of the wall as shown. Which of the following is closest to the distance from the top of the ladder to the base of the wall? So again, let's see what we have. Remember, the legs make the right angle. So here, this is my right angle. I know it looks really awful. So the 4 here is a leg. This, what we're looking for, is missing. So we're missing a leg. Missing a leg. And the 10 is the hypotenuse. So we have a leg and the hypotenuse. Now when you have a leg and the hypotenuse, again, you're going to square both sides. 2, you're going to subtract. And then 3, remember our last step, take the square root. Now because I'm subtracting bigger first, so 10 squared, which would be 100, then 4 squared, which would be 16. Remember, we're subtracting because we're finding a leg. So we're missing a leg. If you're missing a leg, you must subtract. Now, let's get our calculator. If I take 100 and I subtract 16, I get 84. And remember, your last step is you take the square root. Second function, x squared, 84, enter. Again, your calculator is going to always simplify the radical. You need this function right here. Notice it's 9.1. The 1 is going to let that remain 9. So your answer again is 9. Last problem. Now sometimes you may have to draw your right triangle. A cable 20 feet long connects the top of a flagpole. So here's a flagpole. Okay, so there's your flag. Christmas, yeah. Okay, so there's your flagpole, and you have a cable that is 20 feet long that connects the top of a flagpole to a point on the ground. So here's my cable. So there's a cable that is 20 feet long that connects the top of the flagpole to something on the ground. That is 16. So right here, this point to the base of the flagpole is 16 feet. And they want to know how tall is the flagpole. So remember, this is our flagpole here. That's the flagpole. So that's our X. They want to find out how tall is the flagpole. Now notice the flagpole and the base is what's forming your right angle. So these are your legs. So this is a leg and this is a leg. But notice we are missing a leg. When you're missing a leg, what do we have to do? We're going to have to square. So you have 20 squared, which will be 400. 16 squared. So 16 squared. That's 256. Remember, we have to subtract because we're finding a leg. Whenever you have to find a leg, you have to square each side. Then you're going to subtract and then take the square root. So I'm going to take 400, subtract 256. I get 144, and your last step is take the square root of that, which would give you perfectly 12. So if we did second function x squared, 144. Yep, there we go. Your answer is 12. So again, let's recap. If you have both your legs, I want you to square each leg, add them, and take the square root. If you only have one leg, you're going to square both the sides, you're going to subtract, and then your last step is to take the square root. And remember, when you have to subtract, make sure the bigger number, which is the hypotenuse, is first. I hope this has been helpful. Good luck in your task examination.